Hello everyone, myself Dasanas. I am from Sri Venkateswara College of Engineering. Today I am gonna explain about the lexical analysis. At first, let us speak about the brief introduction to lexical analysis. That is, lexical analysis is the first phase in the process of compiler constructions. It involves converting of a sequence of characters into a sequence of sequences of tokens. These tokens are used as a parser in the syntax analysis phase to generate the syntax tree. The lexical analyzer, commonly known as a lexer, scans the input character and produces a stream of tokens for further syntactic and semantic. Now we're gonna speak about the definition and purpose of a lexical analysis. Definition: a lexical analyzers or lexer is a program that performs lexical analysis. It takes the input source code and converts it into tokens for further processing by the parser. Purpose: the primary purpose of a lexical analyzer is to simplify the sequence phase of the compiler by breaking down the subsequent input source code into the meaningful units such as identifier, keywords, and constants. That is what it does. Token recognition: the lexical analyzer identifies and categorizes the leximus with the source code, producing token as outputs. In that, there is also error detection. It is responsible for detecting lexical errors such as illegal characters or unrecognized patterns and handling them appropriately. And now we're going to speak about the input of the parser. By producing a stream of tokens, the lexical analyzer produces clean and organization parser for the further. Now we have a brief elaboration of components of a lexical analyzer. That is the first, that is DFA tables. Finite automata are represented using deterministic state transition tables which drive the lexical analysis process. That is the lexical rules. These rules define the pattern of tokens in terms of regular expressions, guiding the lexical analyzer in its tokenization process. Now we're going to speak about the buffer. The input source code is carried character by character, and buffer is used to store the lexims being constructed. Now we're going to speak few points on the tokenization process. At first, that is a lexeme identification. The lexical analyzer identifies lexeme based on the defined patterns and generates corresponding tokens. At second, that is the transition in automata. The use of finite automata ensures efficient transition between states, recognizing the tokens patterns accurately. At last, we're going to speak about the error handling. Any lexical errors encountered during the tokenization processes are promptly detected and also managed by the lexical analyzer. In this automata, there is also regular expressions and finite automata. Regular expressions, these are used to define the patterns for tokens in lexical analysis. They provide a concise and powerful way to describe the set of strings to be matched. And that regular expressions and finite automata. In this finite automata are used to recognize the patterns which are defined by regular expressions. They provide a theoretical basis for the implementation of lexical analysis. Error handling in lexical analysis. In this error handling in lexical analysis, there are three types of lexical analysis, that is error detection, error reporting, and third one is error recovery. At first, in the error detection, the lexer identifies the lexical errors in the input source code. At second, it is the known as the error reporting. It reports the error along with the location and nature of the error. And third, in that error recovery, the lexical analyzer attempts to recover from the error and continue. Role of lexical analyzer in the compiler pipeline. There are three types, that is the input processing, integration with parser, and error propagation. First, that is the input processing. The lexical analyzer processes the source code and generates tokens. which serves as input to the subsequent phase of the compiler. And second, in the integration with parser. It seamlessly integrates with the parser to provide validated and structured input based on the recognized tokens. And third, that is the error propagation. Any lexical errors encountered are appropriately communicated to the higher levels of the compiler for handling and reporting. Next, that is the examples of lexical analyzer in programming language. There are three types of lexical analyzer in the programming languages, that is C compiler, Java compiler, and Python compiler. So the C compiler tells about the lexer in the C compiler and handles in the tokenization of C source code. Next, that is the Java compiler. Similarly, the Java compiler utilizes a lexical analyzer to process Java programs. Next, that is a Python compiler. The Python compiler includes the dedicated lexical analysis phases. At last, we have reached the last part, that is the conclusion and the summary. There are three, that is the key components: enhance efficiency and integrated load. So that is in that key component, the lexical analyzer is a fundamental component of the compiler, ensuring the accurate tokens extraction and error detections. Second, that is the enhanced efficiency. Though the use of regular expressions and finite automata, the tokenization processes becomes more efficient and recursive. At last, that is the integrative role. Its integration with compiler pipeline contributes significantly towards the overall process of compilation. Thank you.